recording now. So today's speaker is Fredrik Heintz from Linköping University. Very welcome. Fredrik will speak to us about trustworthy AI integrating learning, optimization, and reasoning. Fredrik, the floor is yours.
Thank you very much. It's a great pleasure to be here, and I will now kind of share my screen. So I guess I can start by realizing that I choose a different title compared to what I told you earlier. And actually, I'm kind of I was in this. I mean, I've been giving these kind of talks several times before, and I kind of got fed up with my previous presentations. So therefore, I opted to do something, try to do something new. So I will try to do my best here, and I will talk about this trustworthy human-centric AI, and also with the kind of subtitle of why is it so hard to do right, which I do think is a very fascinating aspect here. I mean, that I do think in many cases, many people want to do the right thing, but still it's really challenging to actually do the right thing, often because what's right is not really easy to determine. But hopefully we'll learn something throughout the process. So the plan is that I will talk about for 5 minutes, and then there will be about 15 minutes of questions and discussions. And if you have some quick comments or questions, you can write them in the chat, and I can try to address them right away. Okay, so let's get started. Well, I can also kind of introduce myself. As Olle said, my name is Fredrik Heintz, and I'm an associate professor of computer science at Linköping University. And I've been involved in AI research for more than 20 years now. So I was started as a PhD student working on unmanned aircraft systems. We build fully autonomous flying helicopters in our case. And that was more than 15 years ago. We had this fully autonomous systems. And my work there was really about integrating many different AI techniques and technologies into working and fielded systems, and then running these systems live in real world situations. And I think that has kind of influenced a lot of my work, this really focusing on integration, in the sense that I don't believe that any single technique will solve everything, but rather that we need many different techniques to be able to overcome these challenges. These days, I work a lot both with the kind of more technical aspects in the kind of intersection between learning and the reasoning. So I mean, my background is more on the reasoning side, but I've also been involved in this high-level expert group on the European level and developing these ethical guidelines for trustworthy AI, which will kind of be the starting point of today's seminar here. So yeah, so I mean, in some sense, the background, I mean, everyone knows about, well, actually, that's kind of interesting. Today, most people actually know about AI. And I think it's because we have this kind of really impressive applications like self-driving cars, even though 5 years ago, there were people's expectations of self-driving cars were much higher. But I think it's just a matter of time before they will actually arrive, but probably take a bit longer than people expected to begin with. But also this kind of superhuman performance in a wide variety of different games. I mean, the one that usually come to mind is like chess and poker and Go, of course, but also Jeopardy and StarCraft and Dota, and I don't know what else they have been able to beat us in. So of course, this is fascinates people when the computer becomes better than we are in playing these games. And of course, robots that looks a bit scary and also triggers people's imagination of all different sorts. And of course, behind all of these applications, we then have this concept of AI or artificial intelligence, which as a kind of a, I will not talk about definitions here today, but it's in some sense, the essence is about understanding what human intelligence is, or what this abstract concept of intelligence is, and then embody machines with this kind of capabilities. But what I wanted to start with here today is, of course, the European approach to AI, where Europe has taken a very clear stance that, yes, we want AI. We think this is really important. However, we don't want any AI, but rather we want what we then have called human-centric AI, meaning that AI is not a purpose of its own, but rather a means to improve the conditions for us as people living, working, and being in I mean, from a European perspective at least, in Europe, but hopefully also for the rest of the world. And secondly, that we want this AI to be trustworthy. And the way we defined this in this ethical guidelines was that AI then has to be lawful, meaning that it should satisfy the rules and regulations that are applicable. It should also satisfy 4 ethical principles that we defined. And last but definitely not least, good intentions is not sufficient, but rather we also need a robust and safe implementation. And actually, I think this was one of the kind of key differences from these guidelines compared to many others, that with this kind of focus on the implementation and realization of these systems is as important, maybe even more important than the actual kind of principles that we want these systems to adhere to. So speaking of that, I mean, stating these kind of principles is relatively easy, and a large number of organizations have done so, both before and after these guidelines were published in 2019. But what we did was try to take 2 steps further. So first of all, of course, we have the principles, but then we also defined requirements based on these principles. And then we also did an assessment list. So basically, I mean, to begin with, it was a very long list of questions that you could ask yourself or your team could discuss in order to figure out and to kind of determining whether you were actually satisfying these requirements or not. So if we then look at the principles, so the 4 principles that we set up are all based on fundamental human rights. That was our guiding kind of starting point. We also started very much from this charter of the EU. So those were basically the kind of foundations upon which we built the rest. So the first ethical principle that we set up was this respect for human autonomy. And this is really about that these systems should augment, complement, and empower people, rather than kind of replace them or do things, kind of take away our autonomy. And I think already here, I mean, again, this is something that I don't think anyone would really argue against. But of course, it quickly becomes unclear, where do our autonomy in some sense end, or when do we hand over too much of our autonomy to a system? And I think an interesting example here is nudging. So many of you might have an app on your phone or something similar that to encourage you to maybe eat healthier or exercise more. That, oh, now it's been 3 days since you exercised the last time. Why don't you go out and exercise now, or something like that? And in some sense, the whole purpose of these apps is to help us make better decisions. In some sense, because we are not good enough, or well, you can argue, but we are not able to make those kind of decisions otherwise, or it's harder for us to do so. And probably it's okay if you have installed this app, you have the control, you have configured it, what you think is reasonable, and so on and so forth. But now assume that instead it is your insurance company who says that, oh, if you install this app and you start eating more healthy, you might you do more exercises and so on, then we will reduce the premium of your insurance. And of course, the kind of other way around, that if you don't do this, maybe your insurance premium will go up. And now it's starting to become questionable. Of course, in this particular case, you might have the option of selecting another insurance company, so you still have this choice. But then you could take it one step further and say maybe now it's from the maybe Folkhälsomyndigheten or something similar that say that, oh, we now want to improve the health of the Swedish population, and we do so by asking everyone to exercise more and eat more healthy and so on. So therefore we want you to install this app or something like that in order to improve the health of the population. And so on. And somewhere here, of course, there is some line where maybe our autonomy is being overridden and not. So I think that this is interesting. The second ethical principle is prevention of harm. In some sense, I think this is probably the least controversial one, or I mean, I don't think any of these are controversial, but more easy to understand and so on. So it's really about that we want these systems to be safe and secure. We want them to protect our physical and mental integrity. But if you want to kind of raise issues and the kind of question marks around this, of course, you have this, going back to Isaac Asimov's and his 3 laws of the robotics, where of course the first one is this, that you should not harm any human. And then you have this kind of situations where you have like a terrorist or something that threatens to blow up a bomb or something. And now the question is it okay to harm this person in order to prevent this harm from happening? That in some sense, we might be willing to sacrifice one person in order to save the lives of tens or hundreds of thousands or whatever number there is. And actually, I think there was also someone mentioned recently that they were kind of discussing this and assume that a robot pushes a person out of harm's way, whether this would be okay or not. I mean, you can have this kind of prototypical example of someone crossing the street and they don't look out, and then there's a car coming and you kind of, I don't know, grab the person or push the person so that they're not hit by the car, but maybe they fall to the ground. I don't know, maybe they're even hurt themselves, but less. And how do you deal with that? So in some sense, what harm is okay to prevent even more harm is of course a very interesting question. The third principle is fairness. Again, I think this is something that everyone can easily agree upon, that of course we want fairness in the sense that we want equal and just distribution of both the benefits and the cost. Of course, then we come to the issue of how to define what we really mean by this equal and just. Is it equal outcomes or is it equal resources, and so on and so forth? Actually, I have some pictures of that later on. So I really think, again, this is something we definitely want to strive for, but what we want to strive for is still unclear. And the fourth and final one is explicability. And this is really about kind of understanding what the system does and how it works, on whose behalf it's working. So it's about being transparent and open with the capabilities and purpose. We also have this explanations, which again, I think is one of these very interesting concepts, which of course may sound completely obvious and very good when you say, oh, of course we want explanations. But then if you start digging into it, what does it mean to explain something? What is a good explanation? Then things become much more tricky. And in some sense, I think that's the general thing with all of these principles, is that they are ideals that most people, if not all people, will kind of agree to. But then when it comes to actual realization, operationalization of these, then the real interesting discussion starts. And as I said, we did then 2 more steps after these principles. We also defined 7 requirements, which in some sense are quite similar to these principles. So it's about human agency and oversight. So both about that we as humans are the agents, and that we should be overseeing what these systems are doing. Technical robustness and safety, privacy and data governance. So this is related to the data, of course, that we shouldn't share sensitive information unnecessarily. Transparency, diversity, non-discrimination, and fairness. So in some sense here, it's also been broadening. That's not only fairness, but also diversity, which actually I think is a very important part. And then societal and environmental well-being. So in some sense, going beyond the individual human and looking at both society at large and even further on the kind of environmental well-being. So broadening the perspectives. And the seventh one is then accountability of these systems. And in some sense, I think one of the, at least from my perspective, key things that we wrote in these guidelines is that none of these requirements is something that you can basically check once and then be done, but rather you need to be continuously both monitored and evaluated throughout the lifetime of a system. So maybe it's more like we have in Sweden here, with that you have to do a yearly checkup of your car to make sure that it's still road safe and so on. That maybe that's more what we need here, rather than having a, I don't know, certification or quality assurance process that you do once and then you're done. We probably will need something more continuous. And also, I think many of these value-based aspects is something that also changes over time. So, I mean, what we consider to be important in our society today might not necessarily be what's considered important in the future. So here, I think we have another interesting challenge related to all of these concepts. And the third third step here was about this assessment list for trustworthy AI. So this was actually kind of the last publication that we did as part of this high-level expert group that was released last summer. So in the original version, I think it was like 131 different questions that was then evaluated. So I mean, a number of organizations tried out these assessment list. There was also a pilot study with a smaller number of companies and organizations that was led by Virginia Dignam from Umeå to kind of try out these assessment lists. And then based on the feedback, we did a significant, basically, more or less rewriting the whole thing and making it much more focused and specific based on these 7 requirements. And there is also an online tool, or not online tool because we don't want to share. So actually, I think this is another very interesting aspect and kind of consideration, is that we really think that this assessment should be done kind of in private, that this is some internal process that you do in order to improve the quality of your service or product or what you now are developing. Because if you start making it public, then it becomes much more important to make this look good. And if it's more about making things look good than actually being good, then there might be concerns about the validity of the answers. So therefore, we actually opted for make part of the internal development process. Okay, so that was a kind of introduction to this trustworthy, human-centered trustworthy AI. Now I wanted to bring up some of these issues. Why is it so difficult to do the right thing? And the first example I want to use here is the following. So, I mean, these are pictures of faces that look like just like normal people like you and me and so on. But of course, the interesting thing here is that these are then computer-generated faces. It actually comes from this website here, thispersondoesnotexist.com. And so what we have here is that a computer has been trained, or I mean, algorithm has been trained on real human faces, and then learning a generative model which allows us to generate new pictures with faces that look more or less like real faces. And I think this is a very interesting example from a number of different perspectives. So first of all, it kind of asks the question, what I mean, that today it's basically possible to generate text, sound, video, and so on, which is more or less indistinguishable from something that was actually recorded from reality. So in some sense, the first question becomes, what is real and what is fake? Because you could take the example of, I mean, basically any magazine, basically every picture in a magazine is photoshopped. So, or I mean, manipulated in one way or the other. And then the question becomes, how much manipulation can you have and still being, in some sense, true or non-fake? Another interesting question that's being raised by this is, how do we determine or what are the kind of what are we allowed to do with this? So actually, I had discussions with some lawyers, and it was not really about faces, but about other synthetic generated data. If someone happened to have the same, I mean, look the same or do the same as this synthetic data, we would violate that person's integrity. So even if I had absolutely no information about this person, it's just by coincidence, we generated something that reminded of this person. They were arguing that we are then violating this person's integrity. So, I mean, take these images as examples. I mean, first of all, it's hard for us to know if there isn't really a person that looks like this, but assume for the sake of argument that there is no person that actually looked like this today. What happens if, say, in 10 years from now, a person is born that looks like this? Are we then violating that person's integrity by just coincidentally generating an image that reminds of them? Or is it actually the other way around, that in some sense, maybe we take the copyright on this image? So now it's illegal for you to have this look and feel, because now we own this face. And I mean, so there are some interesting questions related to that. But what I also think is interesting is this duality between, of course, this kind of techniques can be used to fool people in, for example, believing that, I mean, a safety issue that could arise here is that you get a video call from someone that looks like your boss or, I don't know, family member or something, and they get you to do something, to, I don't know, send money to something. And then it turns out you actually were, or open a door that gives access to some important building or something like that. And basically this kind of social engineering that's often happens. And then because you were tricked into believing that it was someone else. So of course there is this safety concerns, and of course we have the whole fake news debate and so on. But at the same time, there's a lot of information, for example, related to medical information, which we currently cannot use due to the fact that we have this privacy and integrity regulations. So then one opportunity is that we can use this sensitive data to learn models and then generate synthetic data which cannot be traced back to these individuals. So in some sense, we generate synthetic data with some of the properties, namely the kind of statistical patterns of, I don't know, medical aspects, but we don't want to keep some parts of the data, namely this connection to these individuals. So similar to these faces. So we can use real faces to learn how to generate synthetic faces. And then we can use the synthetic data without violating maybe someone's privacy. And actually, this is something that I'm doing research on to generate this kind of synthetic data. So I think it's not clear that these techniques are kind of good or bad in themselves, but it's clear that they have both good and bad usages. And I think that's kind of one challenge here. And I could say make the same argument for, say, facial recognition, for example. And then I think another very important question or interesting question, what is the right answer? So here I just took an image from a course that Thomas Schön is given at Uppsala, but basically the data that you have are the black dots. And now the question becomes, I mean, yeah, this is the data, but what is the right answer? And the answer here in this particular case is some polynomial function, or some function, which of course could be a neural network or some other kind of way of approximating it. But the whole point here is that, I mean, we do have these individual points, and somehow we have to fill in and generalize from these particular examples. And there are basically infinite ways we could do this generalization. So I mean, if we just take the kind of polynomial case, of course, if we have a degree, I don't remember if I never remember, it's one more, one less than the number of points, then we can approximate these points exactly. So it's we can define this polynomial so that it exactly matches these particular points, but usually it will not generalize well. So therefore, there's a lot of different techniques, and here it's just more about regression, but finding different ways, different kind of biases that improves the quality of the answer, that generalizes more. So I think this is kind of the key to machine learning, is really this: how do you generalize from a small number of examples? So you have a limited number of examples, and then you want to say something in general. So basically induction. And of course, then the question becomes, what is the right answer? And in some sense, we don't really know. And of course, it also relates to this with bias, that, I mean, now that we have more these data-driven approaches, we become sensitive to the bias either in the data or in the world. And in some sense, I think this is a kind of most common type of bias is, of course, the one where the data does not represent reality, where the data that we have collected only, for example, covers some groups, but not everyone in society. However, that's relatively straightforward to deal with, because in some sense, it's just about collecting more data. And hopefully over time, you're kind of collecting the data in an appropriate way. Hopefully you will sooner or later have a relatively representative data set. And now they start to do some drilling in my house, so hopefully they don't continue too much. But what's more interesting is when the data that you collect is biased, not because of the collection process itself, but because the world is biased. And here I think you can use this example. I mean, the kind of American criminal system, which has kind of been brought up in many studies, where the judges are more likely to sentence colored people to more harsh punishments, and also that they're less likely to release them on parole. So if you use this data to, for example, assist the judges in making decisions about who should get parole and who should not, then if you don't do anything explicitly, this bias will kind of perpetuate throughout the system, and the data will be trained on this biased data and continue to make biased decisions. However, here the problem cannot be solved by collecting more data, because the kind of world is biased itself. So it means that there needs to be some active intervention or manipulation of the data to remove the bias that we don't like or we don't want. And then that means that someone needs to make this intervention, and someone needs to decide how should the world look like, and then basically adapt the data, manipulate the data to fit that picture of the world. And then we could train the system on this less biased data. I'm not sure I believe that there is any non-biased data, but at least less biased data. And here, actually, me and Stefan, who's in the audience, we had some interesting discussions with Arbetsförmedlingen, the kind of an unemployment agency in Sweden. And then the question becomes, so what is less discriminating? I mean, we know that the work market is basically it's biased. So what is less discriminating? Is it to give advice on an ideal view of the work market? What is it? Arbetsmarknad. Now I cannot speak. So we talked about this earlier, speaking English or Swedish. Now I cannot speak English anymore. Anyway, so I mean, is it more discriminatory to make decisions based on an ideal model of how the unemployment market works, or is it more discriminatory to actually look at the way the unemployment or the work market works in reality? So, for example, I don't know if no, I don't want to give an example because there would just be discriminatory examples. But I think that's a very interesting question. What is the kind of least discriminatory in that particular case? And then we had this aspect again of fairness. So assume that we now can remove the bias. I mean, how do we make sure that we have this kind of impartial and just treatment? And actually, I think it's also related very much to bias. And in some sense, I mean, the first aspect is, do we want to have equality in the sense that everyone should get equal amount of resources? Or is it more equity where we want the same, or do we want everyone to have the same outcome? So is it about the kind of resources that we have available, or is it the outcome? And I think actually here we have a very natural example in Sweden, which is kind of ongoing discussions. That is about the money that the schools get for the pupils. And basically, currently, it's an equality model where every pupil has the same amount of money. So basically, the amount of money a school gets is only dependent on the number of pupils. But probably, or I mean, it seems reasonable at least to assume that the cost is very different, that some will require more support of different types. So of course, then it becomes a fairness question, because if you divide the money based on equality principle, but the cost is very different between the individuals, if you can then select the subset of individuals so that you only get the kind of, what you say, easy, the ones that incur less cost, but you get the same amount of money, then you make a benefit there, and the other way around, that your costs increase, but your income does not increase. And then, of course, this raises all these interesting fairness questions. But actually, it becomes even more challenging because you can look at many different other aspects. So in some sense, you want your should you take into the different sizes of the groups? Is it the shares of the groups, and so on? So I mean, there is a large variety of different measures of fairness. I will not go into the details here, but I think that's an important part, that it's not clear exactly what we mean by fairness, and what can be fair can also vary between situations. And I remember also listening to a talk where there was a lot of challenges about related to this, where if you kind of overcompensate, it might have consequences. And then another part is this explainability. I mean, the right to an explanation has gained a lot of interest based in the GDPR and so on. And in the US, there has been this large research program called Explainable AI, where the whole purpose is to build systems that allows us to understand why these systems come up with these recommendations or suggestions or decisions and so on. And what I think is very interesting here is that they kind of look at three different parts. First is the explainable models. So then it's the models themselves. So I mean, here of course we are this kind of stereotypical example that now we have a decision tree where we have kind of symbolic yes and no questions, and we can basically look at the set of questions that are being answered yes or no, and then we can trace the path through this tree to the decision. And then with the, oh, we believe that this is an explainable model. On the other hand, we might have this deep neural network with, I don't know, 1 million parameters, and then we say that we don't understand how this system reaches its conclusions. And here I'm a bit, what to say, skeptic to both both arguments, actually. So if we take the decision tree for one example, I mean, that's just a matter of size. Assume that if you have, I don't know, 1 million rules in your rule-based system, I'm not sure it makes things more explainable. And if you take these neural networks as another example, I mean, I would argue that they are fully explainable in one sense, namely that, I mean, a neural network only represents a mathematical function. And of course, it's fully determined exactly how to compute that mathematical function. The challenge is, of course, that these are more distributed representations. So there are no, I mean, symbols that are easy to pinpoint, but rather there are many millions of parameters that contribute to the final outcome. And so in some sense, I think the key to explainability is really abstraction. That what we need is to abstract away a lot of the kind of details, and doing this is, of course, I mean, that's a challenging problem. But anyway, what they're interested there is this getting more explainable models. But then they also realized the importance of these interfaces, and here I think that's really a key here, that it's basically about making people understand, which means that I think one of the kind of key things that is that we want to be able to ask follow-up questions, and we might want to test our understanding of something by interacting with the system. So then it becomes really this kind of human-computer interface or interaction challenge. But then they also have a third part, which is the psychology of explanation. So looking more at the human side, which actually I think is quite interesting. I mean, how do explanations work in people? And actually here, I mean, not really about the explanation, but more regarding trust. Me and Stefan Larsson, we have a project about this consumer trust. So what is it that makes consumers trust, say, an online service of some sort? I mean, what do we as consumer really require to trust the system? And I think here one could probably find very interesting things about this interaction between the human psychology and the way that these systems work. And I mean, here Lime is one of these kind of examples of explainable or systems for explaining, in this case, images. So basically using machine learning to identify what parts of an image contributes the most to a particular classification, in this case, that this is some particular frog. And then you can look at different subsets of this image and see what the probability is. And then you can build a model how different parts of this image contributes to this probabilistic classification. So just as one example. Which actually leads me to the next interesting question. How do you evaluate AI systems? So basically, how do you determine whether an AI system is doing the right thing or not the right thing? And actually, maybe I can just start with this particular example, because I think this shows it, because you have this probability. So here this system has classified that this is a tree frog with probability 0.54. But what does that mean? I mean, how do you determine that is a, correct or at least reasonable probability? I mean, in some sense, either it is a tree frog or it's not a tree frog. There, I mean, as far as I know, there's nothing that's like partially a tree frog. Maybe you could argue that, well, there is also a heart in this image, I guess, and maybe that maybe it's the 54% of the pixels is a tree frog, and the rest is not. Maybe that could be. Or I mean, how do you interpret these probabilities? And secondly, how do you use these probabilities to make a decision? I mean, probably if a tree frog or not might not be the most, what you say, life-dependent decision you would make, but assume rather it was be a self-driving car, and there is a probability that there is a human right in front of the car. What probability should it react to? Is it sufficient to have 10%? Does it need to be 50%? Where should you put the threshold? Probably if you put the threshold too low, it will just stop all the time. If you put the threshold too high, you might risk running over people. And how do you evaluate whatever choice you make, whether it's the right one or the wrong one? How do you argue about that? And here I usually use the example of weather forecasting. So I mean, people like to complain that, oh, it says that there was 80% chance of rain, but there was no rain. But actually, that does not mean that they were incorrect. I mean, maybe that was actually the correct forecast. Yeah, I mean, in order to determine that, I mean, actually, this is probably an area where Uli is much more an expert than I am. But I mean, in some sense, you have to look over time and see that if in some sense 80% of the times where they have made this prediction that it's an 80% chance of rain that actually rains, then it's correct. And I really think this is really an interesting question. But going back to this particular image and this AlphaGo system. So here, I mean, when they played against both Lysidol, which the game on the right, and also when they played against KI, I mean, there was several times where the computer made moves that humans would not have done. And of course, here, the kind of comment by the human expert commentators during the game were basically that, oh, now the computer made a really stupid move here because a human would not make this kind of move. And of course, the system won, so apparently it was a good move. But how do we determine whether this particular move was good or bad? Because in some sense, it's very hard for us to judge whether, in some sense, what is the kind of right, but rather we can see, does it do like we normally do? And apparently this was a case where the system was not playing like we normally do. And therefore, the kind of initial reaction was that this was a bad, or at least, well, surprising move. But then afterwards, the kind of interpretation was more the other way around, that the computer actually managed to find a new move that we thought we didn't think about to start with. And now you can assume, or you can change the setting and say that instead of a computer game, or I mean, instead of a game, it is now a decision support system. That now it's a decision support system, maybe giving a recommendation to a medical doctor that, oh, we believe that this patient has this potential, has this disease based on this information, and go completely against the kind of expectations of this medical doctor. How should that medical doctor then say that, I mean, maybe it is right, maybe it's not right? How should I know, in some sense? And I mean, I think this also raises the question of this meaningful human control. How do we maintain this meaningful human control if we cannot determine what the system is doing is good or bad? And of course, in some sense, in order to determine whether it's good or bad, we need to kind of make things play out, and then afterwards, we might be able to determine whether it's good or bad. So I think this raises a lot of very interesting questions. So I see that my time is running out as usual, but I also wanted to say, I mean, there was this paper that came out was 2019 about this right for the wrong reason. So basically here the system were right, I mean, in many cases, but then they kind of, so this was about this kind of question and answering systems. So they evaluated the kind of state-of-the-art question and answering systems, and it turned out that they were quite accurate when it comes to the positive, in this case, positive question where the answer was yes. But if they then basically tweak the sentences somewhat, as it becomes a kind of a negative, so the answer was no, then these systems performed much, much, much worse. And they analyzed this and basically came to the conclusion that probably this sophisticated system were basically using relatively simple heuristics to basically analyze these sentences. And that kind of explained a lot of things. So they then argue that this is right for the wrong reasons. And they also looked into this the evaluation data. And it turned out that these systems performed very, very well on the positive cases, but they performed very, very poorly on the negative cases. So the positive cases is top one, and negative cases are the lower one. So these days, every time someone says, "Oh, we get 99% accuracy," my first reaction is always, "Well, you probably haven't really captured the real thing, but I mean, the evaluation that you use is probably oversimplified." So I think this is really important. This, how do you evaluate these systems, and that is really, really difficult. I think I'm reaching towards the end here, but I think another interesting question that I've been thinking is this: is the problem that AI systems are too good? That in some sense we see a problem when the systems are performing better than we are. Maybe the title is not particularly correct for this example, but the example I usually use is actually voter voter marketing, or election marketing. I mean, of course, an election is all about that the politicians want to convince you to vote this way or that way, or of course to vote for them. And in some sense, the better they are at their kind of marketing, maybe the more likely we are to vote for them. And now that we have these kind of automated systems that are able to relatively accurately pinpoint the voters that are kind of on the edge between different alternatives, and then provide them with the material that will convince them to move either way, then we think this is very challenging our democratic system, because it's too good in identifying these uncertain voters and providing them with information that make them change their minds. But if there were humans doing this, then we would consider them to be skillful people that are able to reach their voter groups and convince them to vote. So I really think this is interesting. And but this particular example here was related to using analytics in the court system. So basically, I think there are two parts to this. The first part was that the French judicial system released data about made data about their verdicts available digitally. And of course, someone started to analyze these judges, how they were making decisions, and came to the conclusion that, well, it depends more on who you get as a judge than the actual information in the particular case. So that the same kind of information will give very different outcomes depending on who is proceeding on that particular case. And probably this is not surprising to many people. But when they published this report, then the kind of reaction from the judges was not that, maybe we need to improve the way we make decisions, but rather it was, this should not be allowed. So then they introduced this ban, making it illegal to do studies on individual judges' behavior. And then I found these news articles, and then it was also about apparently it's becoming more common that you try to predict how different judges react to different evidence, for example, and then trying to use these predictions to improve your chances of winning the cases. So now it's actually illegal to use this kind of analytics tools in the French legal system. But again, this is an example of where if people were to do this, I mean, if you have, I mean, usually it's where you want to, you might be willing to pay a lot of money to get a good lawyer that is the most capable of arguing for your case. But here, maybe a computer system is better at doing this, then we don't think it's okay. Then we don't like it. So I think that's, again, interesting aspect. So some sense to kind of summarize all of these things is that there is a lot of research challenges related to all of this, because I mean, I don't think there are any obvious or clear answers, but rather we need to study all of these different aspects in much more detail. Actually, I want to skip this, and I mean, yeah, I think this is also pretty clear that it's very important. I mean, actually, I do think part of the solution is that we would probably be able to automate a lot of things, and I think we probably should automate a lot of things. But I really think this combination of humans and AI is kind of strictly better than either on their own, and that it's really the question of how do we leverage the kind of strength of both humans and the strength of these more automated systems, and how do we combine them to make even better decisions. Yeah, and then in some sense to come back to this original title about combining reasoning and learning. So if we look at how humans make decisions, so I mean, it's this famous book by Donny Kahneman about thinking fast and slow, where in some sense it's about identifying all the different challenges there is by us people having these two different ways of making decisions, where we have the system 2, which is then the deliberative and conscious, explicit decision process, of basically this idealized version of analytical thinking, where we kind of set up the different facts, and based on these facts we reach these conclusions, and usually it's very much kind of on the logical side of things, where I would argue that kind of traditional, if you want to say more reasoning-based approaches, symbolic-based approaches, they are trying to mechanize this ideal of human decision making. But on the other hand, we also have this other system, which is then called system 1, which is more the automatic, unconscious, effortless system. I mean, I think the best example here is intuition. I mean, if we get a question or if we post with a problem, we intuitively often feel that, oh, this is probably the right answer or the right approach. And in many cases, it is the right answer, but in some cases, it might be completely off the charts. And I think here, these kind of more data-driven learning-based systems are more like this. I mean, for example, this deep neural networks and so on. And because, I mean, another example besides intuition is, of course, perception. I mean, we are extremely good at recognizing objects and people and so on. We see a dot in the far distance and we say, oh, that's this person. And in many cases, we are right. And so, I mean, our perception system is extremely good, but of course, it still makes a lot of mistakes from time to time. And we have no introspection. We don't know how it actually works. Of course, then very interesting research challenge these days, which more and more people are highlighting and addressing, is this: how do we combine these different approaches? How do we combine this extremely accurate, extremely powerful, maybe I should say, learning-based approaches with this more deliberative, explicit, maybe more explainable, but definitely more guarantees when it comes to these more reasoning-based approaches, and how can combine them. So, I mean, my personal perspective here is I really think this is what we need to do, that we need to be able to, and I also think in order to get these explanations, we need to move away from purely correlation-based approaches, which is kind of standard in many of these data-driven approaches, and move towards more causality-based approaches. So we actually have a direction, so we know if we want to change the outcome, what do we need to do, and that we need to build these causal models using both data and knowledge and assumptions. And I think we should leverage the fact that we actually know a lot of things about the world. We don't need to learn everything from scratch every time. And then we can use these causal models both to explain the past, explain things that we have observed, but we can also make better predictions about the future and hopefully more likely. And therefore we have, I'm leading one of these, what's called ICT 48 networks. So this is the European Union has invested in 4 major networks covering different aspects of AI. And I'm leading the one that's called Taylor, where we basically have the scientific vision of providing the scientific foundations for trustworthy AI. And I would strongly believe that this requires that we need to integrate learning, optimization, and reasoning or techniques from these different areas. And of course, we have a large number of partners and so on. So yeah, when I was preparing this, I was trying to come up with some kind of things, and yeah, so some conjectures or things I believe. So I don't think there is a fixed solution to achieve trustworthy AI, but rather it will be some kind of continuous interaction towards better AI systems. I also think that the biggest challenge when it comes to this trustworthy AI and value alignment in general is to agree on what values to align with. So what are the values we really want these systems to have? And actually, I think here a key challenge is that I don't think we will ever be able to encapsulate all the values we want in a single system, but I really believe that pluralism is very important. And I think this interesting challenge that, if going back to this law situation, we require a kind of hard decision. Either you're guilty or you're not guilty. We cannot say, oh, well, it's 67% chance that you actually committed this violation, but we need to say yes and no, which means that I think this is kind of a core to many of the problems. Unfortunately, I have to skip that, which is unfortunate. But anyway, to kind of conclude, AI is all about understanding intelligence and developing the systems of intelligent behavior. I do think that AI will influence all aspects of society, and therefore trust is essential. And according to us in the high-level group and this trustworthy AI, then it has to be legal, ethical, and robust. And there are many, many important and very interesting research challenges that I do think require interdisciplinary approaches. So I really think this move the last couple of years towards broadening the research area of AI from kind of pure computer science kind of technical area into this much broader and much more interdisciplinary research area that it currently is very welcome. But I don't think there is any solution that we all can agree to. And I think the baseline that we compare against will be very important. And I'm not sure that we want to compare against the perfect system, but maybe it's better to raise the lower bar and hopefully also raise the kind of highest bar, but to expect that these systems should be perfect and never make any mistake. I think that's then we will not make use of this. And I also think in the end, what's important is really the combination of humans and AI together if you really want to deal with these very challenging problems. So thank you very much, and apologies for overrunning, using all the time for.
Thank you, Fredrik, for this wonderfully clear and wide-ranging presentation. Time runs fast, but we still have a couple of minutes for questions. Stiliano Katsarou has a question in the chat. Stiliano, would you like to pose it?
Hi, hello. Thanks for this wonderful talk. So yeah, I just made a question. So you mentioned the question about whether we should build models that depict what is happening in the real world, or whether we should create models that do the right thing. And this is maybe a very personal question, but I would like to know what's your opinion about it.
So I mean, my starting point would be, in some sense, the individual. I mean, of course, I mean, if you take this employment example, I think, I mean, in some sense, you want to help this person finding a job. So that to me would be the foundation, and in some sense, it's more. So probably in this case, I would my guess, I mean, my expectation would be that this person probably have more use from getting advice about how the situation really is than getting advice about the kind of idealized and what we wish were true. So in this particular case, I think it's probably better to give more accurate, if you may use more accurate advice. But I think it depends, and yeah. But I think one has to kind of so actually this is very interesting, because I think this is probably a question that you cannot determine kind of from within the system. You really need to take a step back. What do we want to achieve? Why do we want to have this? And then to give you guidance on what is the most appropriate in this particular situation.
Thank you.
Thank you. We have time for one more question. If anyone is up to the challenge. Gordana, do you have a question?
Yes, that was a question that we started to discuss in another seminar. And I would like to hear now more about this. How do you see the possibilities? Because I met this question in connection with autonomous cars. So what is in this car? That's only technicians that know. And people are talking from the point of view of ethics and social and everything. But we need to get technical people into the picture. How do you see the possibilities?
I mean, I'm trying to interpret the question, sorry. So I think, first of all, I do think it's very important to involve more people in the discussion. And I mean, I don't fully buy this argument that, oh, I'm just building a system. I'm not responsible. I mean, I'm just building according to the specification, and therefore I'm kind of without, I don't need to take responsibility. I think you need to take responsibility for what you do and for how the things that you build and develop are used. But I also think it's in some sense the other way around, that I think sometimes people, I mean, coming from a non-technical background, it's easy to put requirements on the system. So in some sense, I think maybe that's the key message of my presentation here, that it's easy to say things like, oh, of course we want our systems to not discriminate against. Of course we want our systems to do not harm people. I mean, yes, of course we agree to that. But then if you look at what does this mean on a technical level, then it's not necessarily as clear anymore. And in some sense, in order to make progress, you really need to take both of these perspectives at the same time. And that's why I think this, for example, this BUSP Humanities and Society research program is so important, because I think that's really a program where you have these different disciplines really mixing and discussing and providing this different perspective. And that's also why I like to collaborate with people like Stefan Larsson and Björn Ola Linner and others that kind of have very different perspectives on things. Yeah, I'm not sure it's really an answer, more that, and I think another aspect is that I don't think ethics and these kind of value-based considerations is something you can add afterwards. It's really something that you need to consider throughout the design and development process. So I don't believe in this, oh, let's have, I don't know, an ethics department within our company here, and that's where all the ethics decisions are taken, and then the rest of the company or organization can do their normal thing. And I don't think that works. I think it's much more a question of, I mean, in some sense, having some sense of, I mean, this kind of ethical compass, whatever you want to call it, that, I mean, it's all these small decisions that you make throughout the process. Those are the important decisions, and the more of them you get right, the more of them you kind of get aligned with the values you want the system to have, the more likely the kind of final product and service will be trustworthy, I guess, in this particular sense, and which of course makes it so much more hard, because it's not something you can just add on. Oh, let's oh no, I don't want to use that. Anyway, but let's just educate, I don't know, 1,000 ethics engineers here, and then we make sure that every organization have their own ethics compliance officer that makes sure that, because that probably, I mean, of course it probably will help, but it would not solve the problem. And it's really about raising the awareness among a much larger group, which is a much harder problem.
I think that's a very important perspective. Whether or not it answers Gordana's question, I think it was worth saying.
I can say it was very, very nice answer. I agree totally with you. Yeah. I like it very much.
Very good. We have to wrap up. Shall we try, if we all turn on our microphones, we can give Fredrik a real applaud. Very well.
Thank you very much.
Ending the